We're going to practice some of the objectives that are in chapter 6. So problems 1 and 2 just say identify the order of the matrices and the individual elements. So in problem 1, we're just to identify the order. So that's 3 rows and 1 column. Matrix B, we have 2 rows and 3 columns. For number 3, we have 3 rows and 4 columns. Then it further asks us to identify the element, lowercase a, that's in the 3rd row, 4th column. And likewise, identify the element, lowercase a, in the 2nd row, 3rd column. For these next few problems, we're going to be practicing matrix addition, subtraction, and scalar multiplication. So given in example 3 are 3 matrices. Might as well go ahead and identify their orders. So this is 3 by 2, same here, and this order is 2 by 2. All right, can we add matrix A to matrix B? Yes, because we have the same order. So the answer matrix will have the same order as the two matrices we're adding. I'm just adding corresponding elements from matrix A and B. Okay, to answer part B here, I'm going to triple matrix B and subtract the double of matrix A. So for me, I'll probably go ahead and bring down 3B here. So I'm going to go back and triple, multiply by 3 every element in matrix B. I'm going to go ahead and put a subtraction sign here to correspond with the difference, and then this is subtraction up here. And then let me record the double of matrix A. Okay, and so now what I'm going to do is just going to go back and do 3 minus 16, subtract corresponding elements. 18 minus negative 2 is 20. Negative 3 minus 4 is negative 7. Negative 15 minus 6 is negative 21, etc. All right, can we add matrix A to matrix C? No, we can't, because when we add, we have to have the exact same order. So I would just say that this is undefined, no solution. All that means the same thing. Okay, for these next few examples, we're gonna revisit how do we multiply matrices together. Not scalar multiplication, but multiplying matrices together. That requires that the columns in the first matrix match the rows in the second matrix. So let's go ahead and identify all the orders here. So for part A, it asks me, can I multiply matrix B times matrix A? So I think right up here what I'm going to do is I'm going to put the dimensions or the order of matrix B. It comes first. So 1 by 3, and then this is going to be where I put the order for matrix A. This is 2 by 2. Since the columns don't match the rows here, then you can't multiply. So we say this is undefined. That's nice. Okay, let's first determine if we can multiply matrix C times matrix A. So we've got an order of 3 by 2 for matrix C, and then A's matrix order is 2 by 2. So yes, the columns match the rows here. So what that tells us is that the answer matrix will be a 3 by 2. So I'm going to go ahead and bring down matrix C here in this space and matrix A here, and then build my answer matrix. So matrix C. I always like when I see a 0, it's going to make some of our work a little bit easier. And then matrix A. Okay. So I go ahead, my strategy is I go ahead and build the answer matrix. So I'm going to have 3 rows and 2 columns. This might be a little close. All right, and I think a strategy to help us remember how do we get each of these elements right here is to write the position of each of these blanks. So this blank is in this matrix, this blank is in row 1, column 1, etc. Row 1, column 2, drop down to row 2, etc. So what this tells us is that we go to the first matrix, we find row 1, and we multiply it by column 1 in the second matrix. So we only take rows from the first matrix and only columns from the second matrix, of which we're multiplying. Just double check, yes, we have 2 elements in this row and 2 elements in this column, so we're going to match them up when multiplying, and then add. When we multiply matrices, we add the product. Determinants, you might remember, is a subtraction of down arrow and up arrow products. But here we're going to add. So this is -4 plus -12. And you can certainly write out that number sentence, -4 plus -12, and then, get a final answer in a different matrix. But this one doesn't seem too cumbersome, so I'm going to try and do all the multiplication and the addition, and then record the answer, the final answer, in one step. All right, now this row needs to get matched with this column, so that product is 12 plus -48. So what about getting these answers? Well, I got to drop down to row 2 and multiply it by each of the columns in the second matrix. So now I'm going to take the second row and multiply it by each of these columns. And there's that nice 0. So multiply 0 times -1, that's 0, plus 14, which is 14. 0 times 3, 0, plus that product is 56. Okay, well, where do we get these numbers from? From multiplying row 3 times each of the 2 columns in the second matrix. So drop down, pick up the last row. -3 plus 4 is 1. And then that product is 9 plus 16 is 25. All right, let's determine if we can multiply matrix B times matrix C. So first let's get the orders of each. So B's matrix is 1 by 3 and C's matrix is 3 by 2. Yep, the columns match the rows here. So our answer matrix is going to be a 1 by 2. So I'm going to pull down matrix B and C right here and then build the answer matrix. B, C. So return to my order of each, and I know I'm going to have to build a 1 row, 2 column answer matrix. So 1 row, 2 columns. 1 row, 2 columns. Alrighty, so we go back. Well, first you might want to do row 1, column 1, and row 1, column 2. So we only have 1 row anyway, and we're going to just multiply it by each of these 2 columns. Noticing that there are now 3 elements in each circled row and circled column, so we do 3 multiplications, adding that all together. So 5 times 4 is 20. 20 plus this 0 plus 3 more is 23. Okay, and the value that belongs right here is multiply these numbers, -30 plus -14 plus 2. Do all that work on a calculator and we end up with -42. All right, what else was in chapter 6? Well, we need to revisit how to find the determinant of a 2 by 2 matrix. It says evaluate the determinant of each of the following matrices. So here's matrix A. How do we get determinant A? Okay, not that this is necessary, but you would come off the brackets because the brackets indicate you have a matrix. When you put these straight bars, absolute value bars, so to speak, or just straight bars, and then record the numbers, this is officially telling us that we're going to find the determinant. Is this step necessary? No, you can go right to this step. All right, how do we get a determinant of a 2 by 2 matrix? Well, down arrow minus, always minus, not plus, that product, which is negative 15. So that's 27. Again, what I'm doing here is not necessary, but it's kind of an official notation of rewriting out of a matrix form to a straight bar saying, hey, I'm about to find the determinant. So the down arrow product, negative 20, always put minus with determinants, and then that's going to be negative 20. Change to addition. When you sum that, you get 0. Just remembering that the value of a determinant can be positive, negative, or 0. All right, let's go to 6. We're going to find the determinant of a 3 by 3 matrix. It says evaluate the determinant of the following matrix. Use the expansion by minors method. Okay, and I'm going to go ahead and re-record. Too bad on a 3 by 3 matrix, it's not as easy as doing the down arrow minus the up arrow when you have to multiply 3 numbers. That's too bad it's not that easy. All right, I think we can make some good choices here. It didn't tell us what row or column to choose to do expansion by minors around. So let's choose a row or a column that has a 0 in it. So it looks like this row or this column or this row or this column. Too bad there's not 2 zeros in one row or one column. So it really doesn't matter. I don't know. I guess I'll choose this last row just because I see a 1 and I know that's a factor and it's just smaller. So I'm going to expand around the bottom row. So remember your sign charts. We determine what row or column, so circle it, and then go ahead and put the positive and negative signs above these factors. So in our sign pattern chart, this would be positive, negative, and positive. So we'll start with 4, the factor 4, it's positive 4. And its minor is what you get when you cross off the row and column. So the remaining elements are these right here. Now I'm going to move over here to the second factor. It's minus this number, so minus 0. That's not going to matter what's in here, but we'll go ahead and officially set it up. So let's remove the row and the column, and we have 0, 1, 3, 2. Move to the last factor, so that's plus 1, which is nice, times the remaining elements. I don't even need that 1 there, but you can put it. It's not necessary. All right. So 4 minus negative 1. Here, I'm not even going to fill anything in because it won't matter when I multiply by 0. And then over here in the last determinant, that's 0 minus, and then that product is 6. So 5 times 4 is 20. Remember, that's 0. This is negative 6 times 1, so that becomes subtract 6. Final answer is 14. All right, and something else in this chapter that we want to review is Cramer's rule to solve a system of equations. All right, so we have 2 unknown variables here. We have x and y, so I'm going to go ahead and set up the formulas. So x is going to be found from the d subscript x determinant in d, and then y is going to be found from this quotient. So the denominators are the same from the same determinant, but the numerators are different determinants. Okay, remember the d determinant comes from the coefficients, not the answers of 10 and 11. Let's replace the x column with the answers of 10 and 11, but keep the y column, and then likewise with the d subscript y determinant. Okay. So calculating these. You do that all on your calculator, you should get negative 14. I think that's negative 28. And that difference is 14. So those numbers look good. That one wasn't too bad. Okay, and just for the sake of doing one more system of linear equations with 3 variables using Cramer's rule, I've got one more problem, but I didn't fit on this page. So if you want to do this linear system of equations with 3 variables just for extra practice, I'm going to work it out on paper, and you guys are welcome to do the same too. If you feel comfortable, then, you know, attempt this problem on your own, come back and check my solution to see if it matches yours. Now, given a preference for this problem right here, if I was given a preference on how to solve this, personally, I'm not going to use Cramer's rule. And I'm not going to use Gaussian elimination where you have to change this to an augmented matrix and do all those row operations. I'm going to make mistakes in both of those methods. I am more likely to make less mistakes if I were to solve this system by choosing one of the variables to eliminate by choosing 2 equations at a time and getting down to a system of 2 equations with 2 variables and then going from there. So for me, I'd probably get rid of the x's just because it'd be easy to change one of the equations to a negative x and add to the other. For me, that'd just be better. But if you're not given an option, then and you're told to use Cramer's rule, then we've got to proceed the way we're about to. You know, whatever you want to do on your homework, on your tests, if it's not asking you to see steps of Cramer's rule, then you choose the method that you want to use to solve. All right. I like to get these set up and ready here. Try and leave a little space underneath here too. So I might want to drop down a little bit for each of these matrices. We're building the coefficient matrix. The answers get replaced in the X column and the other columns stay the same. And the Y column gets replaced with the answers. The other 2 columns stay the same. Doesn't look too bad. The numbers don't look too rough. And replacing the last column, the Z column, with the answers. Okay. So let's go back and calculate these 4 determinants. Then we'll have everything we need to find the ordered triple that satisfies this system. So matrix D, I look for zeros, but I don't see any because I certainly would choose a row or column that has a 0 in it. But I think I'm just going to choose the top row. It just has a bunch of 1s. Okay, so lightly circle, and then don't forget you put your signs above here. Oops, that's a little wet. Plus, minus, plus. So 1 times the remaining minor. Okay, and then we have minus 1. And then we have plus 1. I don't need to show this 1. I can just go right to the bracket, but this is going to be minus and then another bracket and plus another bracket. So -4 minus 3, 2 minus 1, 3 minus, that's going to be -2. We've got -7. Let's do this work first. That's just 1, so -1. And then in here we've got 5, so plus 5. So this looks like -3. Okay, I don't know, choose the last column, maybe. Those are the smallest numbers. Whatever you want to do, we should get the same answer if we haven't made mistakes. Put the signs above them. So this is positive, negative, this is positive, and they alternate minus and then positive. Drop down here, this is -1, find its minor. And drop down here, +2 times its minor. All right, I don't need the 1. Don't need the 1 there, but I do need the 2 here. Looks like that's 29. This is 8, so subtract a 8. Plus, and then I'm going to have 2 times, and this is -15 in here. So 2 times -15. All right, let's see what that is. That's -30. So that's 29 minus 8 minus 30. So that's 21 minus 30 is -9. Which that's a good number because I'm going to end up putting it over -3. So it looks like my x value is going to be 3 when I come back up here and use this formula. So good, nothing there indicates that I made a mistake. Okay. I think I'm going to return and use this first. I'll use the first column. So plus, minus, plus. Again, you can show the ones in front, but it's not necessary. So we've got 10 minus, this is 4 in here, plus, and then this is -3. So that is what? 6 plus -3, so 6 minus 3, that's 3. Well, that's perfect because I'm going to take 3 to get y. I'm going to take 3 and divide it by -3, so that's going to be -1. So far, so good. And for the last determinant, I'm going to again choose this first column here. Oh, I forgot to put the plus, minus, plus. That's important because you have to know what sign goes here. I really recommend immediately putting the subtraction after your down arrow. And the up arrow product is -8 here. That's where a lot of mistakes could be made. All right, and here's -29 minus, and here is -8. So that's minus -8. I'll change that to +8. And then over here, this is 15. So we'll hope for the best. That's 23, so that looks like it's going to be -6 if you get out the calculator. I know that was kind of quick, but we've got all the values of the determinant, so let's go back up to the top and find the x, y, and z values. Okay. All right. Kind of do this here. What's that? -9 over -3. And y was 3 over, always the same D, -3, all the same denominators. And the last one was -6 over -3. So X is 3, Y is -1, and Z is +2. And I'd want to record it as an ordered triple, 3, -1, 2. All right, that's it.